Okay, in this next section, we're going to start talking about slope of lines. We're going to be writing equations of lines. And essentially what we're going to end up doing is looking at parallel and perpendicular lines. You may be thinking, this is algebra, why are we using it? Dealing with parallel and perpendicular lines, as y'all know, is geometry, and that's what we're working towards. So a lot of this you may remember from algebra, some you may not. And that's what this video is for, is to refresh your memory and focus on some of those things that you need to practice again. So slope. I've got this picture here. You may have seen this driving before. Obviously you weren't driving, but with your parents in the mountains possibly. This is showing the steepness of, let's say, you're coming around a hill. It's showing the steepness of this hill. It's telling you the grade of the incline or decline. Slope, when we talk about slope, that's what this sign is referring to. It's a measure of the steepness of a line. Slope can be positive. It could be negative. You can have a slope of 0, or you can have an undefined slope, or no slope at all. And we're going to look at how each of these are different. So in this one, we've got this little figure, and we're always moving left to right in the coordinate plane. So as this guy goes up, as he moves left to right, he's going uphill. Same with this little bird that happens to be skiing. They're going up. They're increasing as they go. So this would represent a positive slope. This guy, on the other hand, if you go left to right, which we always, when we read a coordinate plane, we're looking at it from left to right, what's happening. He's going downhill. Same with this little bird. It's a downhill slope. That represents a negative slope. Okay, this guy, he's just walking straight across. Same with this. There is no incline at all. We say that has a slope of 0. And this kind of line, you want to ask yourself, what kind of line is this? You have diagonal lines, which either go up or down. We have lines that go straight up and down, and we have lines that go straight from left to right. This line, when we have a 0 slope, is a horizontal line. This line, it's going straight up and down. It is a vertical line. And when we have this slope, think about this bird is going to go straight down to the ground. This is going to give us an undefined slope. You can think about each of these. I'm going to go back to the other graph. When you have a 0 slope and it's a horizontal line, think about you can start to make a 0 with that line. Hence, 0 slope. When I go to my vertical line, if I try to make a 0, it's not going to form with this vertical line. What I can sort of form is a U, representing undefined slope. Now, there are many ways to find slope. We can look at a graph. We can just look at the overall picture, and we can tell if it's positive, negative, 0, or undefined. But we can also look at a graph, and we can count. We also have formulas. When we think about slope, we said it's the steepness of a line. It is the rate of change is another way we phrase slope. It's the rate of change, because when we look at slope, we're looking at our change in y over our change in x, which most of you probably remember it as being the rise okay, the change in the y values, over the run, the change in the x values. And some of you may recall your formula that you use when you're doing this. When I look at change in y, what does change mean? Change means difference, how they're changing. So if I have two ordered pairs, oops, we don't start with y. We always start with x, then y. And if my second ordered pair is x sub 2, y sub 2. Remember, these are just labels. It's just representing two different points that we could have. When I look at change in y, I'm going to look at the difference of the two y values over change in x, which means I look at the difference in the two x values. You have to make sure that if you start with point y sub 2, you start on the bottom with the x sub 2. They have to line up. You have to start with the same point. So let's look at how we could figure this out on a graph. Okay, so I've got this line on this coordinate plane, and I want to find the slope. The first thing you want to do is you want to look for good, solid points. Okay, a good point to find is always on the y-axis. That point right there, and that's really too big to be able to even see exactly specifically what I'm talking about. So if I look at this point right there, there's a good point. It crosses where two boxes meet. Now, if I go to that point right there, see how that's in the middle? We don't want that point. That's not a good point to use. We want to use two good points. So I'm going to use this one, and this one crosses at the corner again. I could keep going down. There's another. There's another. There's another. Another. And another. Any of those points would work. And remember, we said slope is the rise over the run. So if I'm looking at a graph, I want to figure out how many units am I rising. Now, if I move up, I went how many units up? I went 2 positive units up. And I go how many over to get to that next dot? Well, that's 1. So my rise is 2, my run is 1, and if I can simplify this, I always want to. So this has a slope of 2. Well, what if I wanted to go from, say, this point to this point? Let's look at the difference. When I go down, that's a negative 2 because I'm moving down. If I move to the left, think about on the x-axis, that's moving towards the negative values. That's a negative also. So if I do that rise or run, it's negative 2 because I went down 2 and I went left 1. Well, what is negative 2 over negative 1 simplify? It's a positive 2 as well. Okay, those are the same slopes. It gets you the same answer. Okay, let's look at a new problem where I'm given 2 ordered pairs. First thing I'm going to do, I'm going to show you graphically, and then I'm going to show you algebraically how we could find that slope. Algebraically means I'm going to use my slope formula to find it. Graphically means I'm going to plot my ordered pairs and look at the rise of the run on the graph too. So I'm going to look at it both ways. You'll need to be able to do both ways as we move through this chapter on this. So if I plot negative 4, 6, I always go x first. So negative 4 is to the left 4 units, and then I'm going to go up 6 units. So there's my negative 4, 6. 2, negative 12 means I'm going to go to the right 2. I'm going to go over here, and then I'm going to go down 12 units. Well, I did not make my graph big enough for this point, so I'm just going to put it right there. And then I can go back and erase how I got to that point. So then if I connect those points, my line is a little off. Now, when I connect those points, this is the line that I'm finding the slope of. That line goes through those 2 points. I'm trying to find the slope of that line. So I can see that I moved, if I go from one point to the other, 4, 5, 6 units to the right, and I went 6 and then 12 more. I went 18 units down. Okay, so it's a negative 18 because remember, if I'm going down, it's going to be a negative. So what is the rise over run of that? My change in y was negative 18. My change in x was 6. If I simplify this, I get negative 3. Well, let's try to work this out algebraically, as if I didn't even have a graph. So I'm going to use this formula. So I'm going to take y sub 2, which is negative 12, minus y sub 1, which is 6. Then I'm going to take x sub 2, which is 2, minus x sub 1, which is negative 4. Well, negative 12 minus 6 gives me negative 18. 2 minus negative 4 is going to give me a positive 6. That simplifies to negative 3. So this shows this method was geometrically, this method was algebraically. I got the same answer. So that's going to conclude this part of the video. Tomorrow in class, we're going to start looking at how to graph these lines and how to write equations for these lines eventually. I will see y'all tomorrow.